This is called special case binomials.
That's so sick. I like apples. I like the special case binomials. I like the pastry cakes. I like the chocolate.
Write this down here. Let me show you this. Example number 1. These are things that you will run into that are kind of like special cases. For example, if I have x plus 3 squared, if you have x plus 3 squared, what I usually get when I write that problem on a quiz or when somebody does it for their homework, quite often somebody just goes, oh, well the answer is x squared plus 9. Love the x squared plus 9 answer. X squared plus 9. No, that is wrong. Completely incorrect. Not even close. Not even in the ballpark here. What you must remember is, what does this little squared mean? That you multiply this times itself. And we've talked about this. You need to multiply x plus 3 times x plus 3. It's a binomial times a binomial, in which case we use our lovely little FOIL method. Okay. In the FOIL method, it's the first terms, x times x is x squared. The outside terms and the inside terms combine together to give you a 6x, right? Because it's 3x plus 3x. And then the last term is the 9. This is x plus 3 squared. It's just not as easy as you saying, you don't just square this and square this. You have to square the whole binomial. Another example, what about this? 2x minus 3 squared. It is not 4x squared plus 9. Okay, you have to actually sit down and write it out as a binomial. 2x minus 3 times 2x minus 3. What do you get if you multiply that out? Well, 2x times 2x for the f in FOIL is 4x squared. Your two middle terms, the outside terms and the inside terms, you get a negative 6x and another negative 6x to give you a total of negative 12x's, and then negative 3 times negative 3 is a positive 9. Mary Schubert.
I'm confused because don't you go like that and then times it? Can I show you?
You can tell me what.
It's so hard to take 2x, then you go to the 2x, and then you times them, and then you get, but then you have to do the other one.
You get the what one?
Negative 3.
I did that. Negative 3
No, the other one. 2x times, what?
2x times negative 3 here?
Yeah.
I did that. That was my negative 6x. And this 3 times that 2x is another negative 6x. Those two are like terms, so I put them together, and that's negative 12x.
Oh.
And then negative 3 times negative 3 is positive 9.
Okay.
Yes, yes, yes. Got that? That's special case number 1, ladies and gentlemen. Special case number 2, I've already talked to you about, and that is when you have this. Just something to recognize. If you have x minus 3 times x plus 3, if you have the same binomial except one's addition, one's subtraction, okay, your middle term will actually drop out and you only end up with a binomial. Because when you do the FOIL, you still get x times x, and that's x squared. But when you do the outside terms, the positive 3x, and the inside term, a negative 3x, they're exact opposites. A positive 3x and a negative 3x drop out to give you no x's. You get no middle term. In the end, you get a positive 3 times a negative 3, you get negative 9. So the only time you won't get a middle term with that is when they're exactly the same except they're the opposites. Same thing if you have something like this. 3x plus 6 times 3x minus 6. Okay, when you do that, what do you get if you multiply it out? 3x times 3x is 9x squared. the outside terms give you a negative 18x, the inside terms give you a positive 18x, and if you try to put those together, you get no x's, and then in the end you get negative 36. And that would be the answer to that. And it's important to know, it's important to recognize that when you do multiply these two types of things together, you'll always get a subtraction sign in the middle here. Because there's no other way it's going to work. Because it's always, when you have opposite numbers times themselves, you always get a minus sign. You'll never get 9x squared plus 36, or x squared minus 9. How about that? Those were kind of special cases, weren't they?
I love special.
Let me see if there's anything else they give you. Probably not. Probably not. All right. With that being said, children,